Hi, in this video we're going to look at another example of using implicit differentiation. So we have here an example. We have an equation 3y squared plus 4x equals sine of y, and we're asked to find dy dx. So the reason we need to use implicit differentiation is that we don't have y as a function of x. We can't do algebra to isolate y completely, to write y completely in terms of x with no y's on the other side of the equation. So we need to use implicit differentiation. I've written over here the two main steps. First main step, differentiate both sides of the equation with respect to x. So we're just going to do that with this example over here. So we're going to find the derivative with respect to x of the left side, and that's going to equal the derivative with respect to x of the right side. Okay, so I just wrote down some instructions to myself here that say differentiate both sides with respect to x. And so I use that differential operator d dx applied to both sides of the equation. And so now when I do this, I'm going to just go through and do what it says here. So I'm going to differentiate term by term. In the first term on the left side, I want to differentiate 3y squared with respect to x. Remember, we're treating y as a function of x when we do that. So I've got an outer function here and an inner function. My outer function is 3 times something squared. I'm just going to bring down that exponent and subtract 1, kind of the usual way we use power rule there. But the key thing to remember here is that y is a function of x. So technically I have an inside function here. My inside function is the y inside the 3 times something squared function. So I'm going to have an extra factor here when I differentiate that term with respect to x. This comes from chain rule. Times the derivative of the inside would be times dy dx. Alright, and then for the next term, the derivative with respect to x of 4x, that will just be 4. And then onto the other side of the equation, the derivative with respect to x of sine of y. So again here, I'm going to need to use chain rule. I've got y inside this sine function. So I'm going to differentiate the outer function. The derivative of the sine function is the cosine function. Leave the inside alone. And then times the derivative of what's inside. So times dy dx. So I get these extra factors of dy dx. Those come from chain rule every time I'm differentiating any expression involving y. Okay, so I've differentiated both sides of the equation with respect to x, and now I want to use algebra to isolate dy dx. So I want to use addition or subtraction to get all the terms that involve dy dx on one side of the equation, and then the other terms that don't involve dy dx on the other side. So I'm going to subtract this 6y dy dx term from both sides of the equations. I could choose to do this algebra in different ways, but since I have a term involving dy dx already on the right side of the equation and a term that does not involve dy dx already on the left side of the equation, that 4, I'm going to choose to move the 6y dy dx term. Okay, so on the right side here, I can write these terms in either order. I'm just going to write the cosine y times dy dx term first, and then minus 6y times dy dx. Okay, so that algebra is pretty much the same every time. When I use that algebra to isolate dy dx, one step is to add or subtract terms so that I get all the dy dx terms on one side and all the other terms on the other side. And then the next main step is to factor out a dy dx. So this time on the right side of the equation, I have dy dx that I can factor out of two terms. So I'm left with cosine y from the first term and then minus 6y from the second term. And then the last main step is always the same. You're going to divide by that factor that's times the dy dx that you just factored out. And the goal there is to get the dy dx all by itself. So at this point I actually have the answer. I'm going to rewrite it just a little bit neater here. So I've got 4 over cosine y minus 6y equals dy dx. Okay, so there is my answer. There's different ways you could write that denominator. You could switch the order of those terms. If you do that, you would want to make sure that the minus sign stays with the 6y, and then the cosine y would have a plus in front of it. So that would be another way that you might write that answer. You want to make sure that that minus sign that's in front of the 6y doesn't sneak up and be in front of the fraction and times the whole fraction. It should just apply to that 6y term. Okay, so we'll look at some other examples in some of the next videos.